Hey, what's up, guys? Chung here. Uh, so today let's talk about this problem number 140, word break 2. Yeah, this one is marked as hard. Um, yeah, I would say it's between the hard and the medium. Yeah, it's not that extreme hard, but it got some tricky point you need to think about. So, okay, so let's take a look. So you're given a non-empty string S and a dictionary word dictionary containing a list of non-empty words, and you need to add spaces in S so that all so that all the words you got after adding the spaces are in the word dictionary, and you need to return all the possible sentences here. For example, this one you can add like space and a cat and a dog and yeah, right. So that you have two results here. Same thing for this one. Pineapple, yeah, pineapple, right? So you add here, here, and here. You have basically you have three options here. And for this one basically you can, right? Basically, if you add cat here and then send the an OD, right? Basically, no matter how you break these words, there's no way all the words are in the word dictionary. So in this case, you just return empty, right? So how do you, I mean, think of this kind of problem, right? So I think a very intuitive way will be we just start from the beginning, right? Let's say we start from the beginning and then we just check this. Uh, okay, so we try to break, right? So for each, okay, let's say for example this one, we see a cat here, right? We see a cat and then we see, oh, cat is inside the word dictionary. Then we know we find we find like a word. And then the problem is, how about the rest of the string here, right? So once we have cat here, the rest string here. So the rest string is send dog, right? We want to know with the current word cat removed from the string, can we have a valid like result from the substring, or if there is, how many of them, right? And so that will lead us to a recursive call, right? Basically, so once we find a cat here, and then we just pass the rest of the string to this recursive function method itself, right? And and in the end, so this recursive function will return what? Will return with current as, right? With current as, what are the possible uh, word breaks we can get with the current string, right? And then once we have this part, basically we just simply for each of the possible result returned from this recursive call, we add this cat at the beginning of that list, right? And then we just pass it along, right? Pass it back. So that's how we do the recursive call. Uh, okay, I'll try to write this. So we have a cat, right? So cat send send dog, right? So the first one we find is a cat, right? So so the left side, that this is a cat, right? So this is a cat. And then what about the other side? That's a SANDDOG, right? So since we already have a word here, then we just simply leave it here, right? And then we look at stand here, right? So how about stand? Then with the same word, since we're doing a recursive call, right? And then for the stand dog, we'll also start from beginning. We find SAND Okay, so SND, oh, SND is in the is in this. So we're gonna have like another SA and D, right? To remove from the string, right? And then we're gonna have a this is like the previous, right? Previous, and then we're gonna have a dog here. So here we got a dog, right? Yeah, and with this one, okay, see, oh, so that's so at this moment we're gonna have like another start, another like a recursive call with a string dog, right? And then we with a string dog we see oh we find a dog, right? Then we'll just like uh this one we're gonna find a dog, right? That's the word, right? We that's the word we find from the recursive call, and then the this one gonna be empty, right? In this case, so this one is empty string, right? So that's when we reach the end of the recursive call, right? And with this one, let's see what we have. We have a so one thing to be noticed here. So once you see an empty string here, you need to return like an empty array here, so that when we do the join, so remember every time when we find like a number and and we have this, we'll do a recursive call. This recursive call will will return us a array, right? The array has all the possible combinations we can get from this current string. If it's empty, then we need to return like an empty array here so that it can form a valid result with this dog here, right? That's like basically the so for each result returned from the previous recursions, we just add this send at the beginning and then we just recursive return it, right? We add, right? Then recursive call, we add. And that's how we get the final results, right? So because since we're doing this every time, right? When we do a cat here, we're doing a for loop, right? Basically, inside when every time we have a string here, we do a for loop. We loop it from the beginning to the end. We try all the possible strings to see if we can form like a valid like a word break with the current string with the current word and the remaining strings, right? And then yeah, and then let's take a look at this one, right? This the cat send dog. So in case we cannot form anything, how can this one guarantee that we'll have an empty, right? And okay, so for example, let's say there's like a dog. Let's say the dog is not in the. Let's say the dog was. What? What did I do? Oh, man. Let's say the dog is not inside the word dictionary, right? For example, then at this stage, right? At this stage, basically we'll not be finding this like we'll not find this one. Basically, when we loop through the D, O, and G, we never find a matching word, right? So basically that's when we'll just stop. We'll stop the basically we'll not be returning like uh array of empty array. Basically, we'll just return like an empty list with nothing inside there, so that when this one when this recursive call goes back, uh, this send trying to find anything inside this returned list, it finds nothing, right? So that basically it's not going to create another valid string based on this recursion call, and then this one goes back here. And in that case, this like recursion call will also be empty, right? and then that's how we get this empty in the end. Uh, okay, so let's try to code this thing here. Let's see. Uh, this is like the backtracking concept here. So we're gonna define a backtracking method, right? Backtrack, right, with the string, right? And then what? And the let's see. Uh, hmm, backtracking. Okay, if right, like I said, if not as right, if as is like empty, then we need to return like empty of empty string, right? Because in the end we're gonna, so let's say the current words, right? The current words, what's the current words, right? And let's see. So the current word is gonna be a array, right? And we just do a for loop, right? For character in as, right? We loop through the character from beginning to the end, right? And then what do? We do a new word, right? Let's define a variable here. This new word, that's the as to oh yeah, actually, so I need a index, not the value itself. Length range, right? Length as here. So and basically we get all the words until this I here, right? And then we check if new word, right? If new word is in the, oh yeah. So this is a small trick here. So every time when you see a word list, list type, and you want to compare, you want to do the check, do on an in check in this one, it's always a good idea to convert this like word list to a word to a set. That will speed up the lookup a lot, because if it's a list, the the time to look up an element from the list is on, right? But with the set, it's gonna be one. It's a constant time. So we do it if this one is in the word set, right? And then we just need to pass the rest string into a recursion call, right? We're gonna define another variable here. I would call it rest rest word breaks, right? I think this is good enough. To backtrack, right? Backtrack going to be as from I plus one, right? Starting I plus one to the end of the word of the string here, right? That's how we do a backtrack here. And right, and then for each right, for each the word rest, for each word break we get from this recursion call, right? Word breaks, right? We uh we need to basically we need to append this thing after this new word, right? So and then we're adding it to our current like word breaks, current word breaks. Yeah, okay. Current word breaks, right? Append, right? We append it to the current word break. So how are we doing append? So we're gonna, since this thing is gonna return like a list, right? A list of a list. Yeah, so this word break is a list of word, right? Who got separated by the space. So we need when we do a we cannot do append here, right? Because the append we need this new word at the beginning, right? Otherwise the sequence will be reversed. So we can use a small trick here. So to instead of using append, we can either do a queue to use a queue in here, or we can just do a like do this, right? Do a new word. We put it inside the we convert this new word to an array, right? And then to a list, and then we just add that to the rest of the list of word. In this case, we're gonna have like a new list, right? So that's that. Okay, so and then in the end of this thing, we what do we do, right? We return, right? We just simply return uh current, right? The current word break, right? So basically, this the current word breaks will have the will give us all the possible like breaks uh with the current s, right? Remember here, so we have a s, we have for loop here, right? Basically, we are looping through all the possible words from this s, and then with this like a new word in mind separated from the string, we check. Oh, okay. So if the remaining string can give us a valid rest word breaks, if it is, which means if there is anything returned from this backtracking recursion function, we will be basically we add this new word we already have with the rest of the with each one of returned from this backtracking method. Then in the end we add this one to the we append this one to our current records, right? So here backtrack as, right? So we return basically we can return this is gonna be the word breaks, right? Word breaks equals to that, right? But in the remember in the end, so uh, right now currently this word breaks is a list of lists, but what we want is a list of string, right? So we can simply return like do a join, right? Join by the space, right? Join for word break, right? For oh no, sorry here. Since we're returning like a array a list here, we need to encaps uh break. Okay, for, right? For word break in word breaks, right? That's how we basically it's just simple like simple for loop here, and we add it to array. It's just like a simple way of write it in Python. Otherwise, we can just have another for loop, and then for each word in this one, we just do this one, and we assign it to a list variable. It's just like an easier way to write it in one line here. Okay, so I think that's the basic of this problem, but I think but if you guys look closely, there's like a drawback of this solution. Uh, we are doing a for loop on each of the s, right? And for each of the s, let's say we have a this let's say the s equals to a, right? And then no, it's like a, right? And the word dictionary is like let's say it's a and a a, right? So let's say we have a long list of a here, right? So in that case, right, let's say we loop through the we will loop you know what? Let's say there's like another one here. Sorry. There's like another like word dictionary. It's called a, right? And when we loop through the word dictionary here, so we're gonna have so we'll be finding a, right? So two a's is in here, and then three is also we're gonna have three a's, right? And then we'll keep going into this loop. Basically, we'll find three words in the first for loop, right? A, and the seven A's. And for each of them, right, we'll be divide this one. We'll use a new word, and then we'll pass the rest into the backtracking. So the rest in the backtracking will also be consisted of the of all the A's here, right? So we are basically we're processing the same strings over and for many times, right? Because when we look at this one, look at the rest of the string, they're all A, and we'll be looping through those A's one more time, and then we find A again, three again, and the seven A again. We'll do this over and over, right? That's basically waste a lot of time. So the easiest fix will be we just simply do a memorization, right, with a recursion call, right? So what do? We just define like a mem dictionary, right? With the we can do this. We can do like a dictionary, right? So every time, right, before returning, we save the current. So basically, this memory dictionary will store for current as the key will be the string as, and the value will be a list of lists. Basically, this one tells us for this string as, what are the possible break words it can contain, right? The possibilities for the break of words. So right, as equals to the current word, right? Breaks, and so that, and then before doing anything, we can just simply check, right? If as in the mem, right? If it is, we just simply return the value we had previously processed, right? Yeah, that will greatly improve our performance. Okay, I think that that's all we need to write here. Let's try to run it. Oh, yeah, one. Mm, let's see, what did I miss? Uh, oh my God, here. Yeah, what am I doing here? A return, right? Should return it, right? Return this thing. Cool. Yeah, let's try to run it. Yeah, cool. Yeah, basically that's it, right? So let's do a quick recap here. So the key concept here is for each of the current, we loop through the current as, right? We loop through the current as every time when we find a valid word that appears in the word dictionary, we just we basically we pass the rest string into this backtracking method. And once we get the result from it, we'll do a cross join, right? Basically for each of the results from here, we add our current word to it to to construct a new word break list. And then in the end, we return this list. And then we're also using this memorization like technique to save to speed up the code, right? And then so so if for example, if there's no valid word break for this string, right? So what will happen here? It will so anyway, so in the no matter how many valid word we have already find previously at the last level of recursions, when we do a for loop, right? When we do a for loop here, basically we'll never find this like new words, right? Basically, these new words will never be in this like word set, right? So in that case, we'll just go all the way down here, right, to return. So what are we returning? We're returning an empty list here, right? And then this one will go back to the previously call, which is here, right? Then in the previous call, then so the next line will come back here, and this rest word breaks will be the one returned from here, right? Then what's the value? Which is empty, right? The empty list. And then when we do a for loop, basically we're not going inside this for loop because there's nothing in the rest word break, so there won't be any loop here. And so in that case, the previous the previous recursion call will not add anything to this current word breaks, and then it will also return empty, and then it goes on goes back on and on until it reaches down the top, and this one will also be empty, right? That's how the this problem works, right? Okay, I think that's it for this problem. I hope you guys like it, and thank you so much for watching the video. And I'll be seeing you guys soon. Yeah, bye.